Okay, so example 4, octane is a component of petrol. It burns in oxygen to produce carbon dioxide and water. Energy is released during the reaction, and the equation is here. Calculate the mass of oxygen required to react with 200 grams of octane. All right, so we've got 200 grams of octane, and we want to know the mass of oxygen required to react with 200 grams of octane. All right, so let's just rewrite the equation, make it a little bit easier. 2 C8H18 plus 25 O2, 16 CO2 plus 18 H2O. Okay, so we've got 200 grams of octane. So we're dealing with molar ratios. So of course we need to convert the grams to moles. So 200 divided by the molar mass of octane. So 8 times 12 plus 18 is 114. 1.75 moles of octane. Now I want to know how many moles of oxygen I have so that I can work out the mass of oxygen. So moles of oxygen is the big question mark. So how do I do that? Moles of oxygen, how do I figure that out? I use my molar ratio and I multiply by the mole value that I know, which is the octane. Now the mole ratio that we use is always the coefficient of the unknown over the coefficient of the known. So coefficient of the unknown is 25 over the coefficient of the known is 2 times the mole value that we know, which is 1.75, to give me the mole of my oxygen. So when I complete that calculation, the mole of oxygen that I get is 21.87. Okay, but that's not the end of the question because I want to know the grams. So the mass of oxygen is equal to the mole value that I have of the oxygen times the molar mass of oxygen. So I have 21.87 moles of oxygen and the molar mass of oxygen is 32. Okay, so the gram value that I have is 700 grams. So that's it.